everyone, welcome to this new episode of the Swift Academy podcast. Today, I'm very happy to be with Artem and Bogdan for this first episode of the Swift Academy podcast. Hello, Artem and Bogdan, how are you?
Hi.
Hi everyone. We're good, I think. Thanks for having me.
Yeah.
It's a pleasure to be here today.
Excited to be back on the podcast. So let's see what are gonna cover today. Pretty exciting topics.
Yes. It was a great episode with you for the season 1, Bogdan, about legacy code. And I think for Artem, for first time, we discover we are together to speak about great topics that I think that today a lot of developers care about this topic, but not a lot of developers fully understand, which is performance. We all want fast applications. We all want smooth scrolling, instant interactions, and quick app launches. But what is interesting is that performance has become much harder to reason about than it was a few years ago. Today we have, as you know, SwiftUI, Swift Concurrency, powerful device compared to the first version of iPhone or Mac or iPad or the Apple devices.
Yes.
We have also a lot of SDK, dozen of SDK that Livid Analytic SDK as a famous example. We have also complex architectures and more abstraction using protocols and stuff like that. Yet users still complain, even with this kind of things that we have, and people said, okay, but the application it's not performant. That's why I want to invited you to speak about a lot of topics related to performance. My question is for you two. To my first question, for you, what does it actually mean today when we say an iOS app or macOS app, it's performant? And how do you decide whether a performance issue is worth fixing? I don't know. Maybe we can begin with Artem.
This question is both simple and complex, I think. But for me, a performant app, iOS app, is an app that stays responsive under real world conditions. So, of course, speed matters. Launch time, frame time, networks latency, memory usage, all of that matters. But users feel sometimes something simpler than that. Then they feel like, did the app react to my tap? Did useful content appear quickly? Did scrolling stay smooth? So I usually think about performance as a chain. A simple tap can trigger network work, decoding, model, mapping, layout, and one of that chain gets too, if one part of that chain gets too heavy, the whole interaction starts to feel slow. And quite often it's not one function, it's a lot of, it's reasonable work, but happening at the wrong moment. So screen may feel perfectly fine on a couple devices in the office. Then it goes to production and we face with the reality, and it can be much messier than that. Older iPhones, iPhone 11, 12, maybe earlier models, unstable network, different payloads. So if fit may feels smooth on iPhone 17 Pro and can start hitch on an iPhone 12, for example. So that's why I don't like guessing with performance. Instruments, signposts, MetricKit, we use different production dashboards, whatever helps us to understand where the user actually pays this cost. Otherwise, it is very easy to make the code base more complicated just to save a few milliseconds. A wrong milliseconds nobody will ever feel. I believe that performance needs shared ownership, because one team may add an SDK, another adds more startup work. Each change may be reasonable on its own, but together they change how the products feels for users. And it's not only about metrics and feelings, it's about business too. It matters for business. Today, users are used to instant content like TikTok, YouTube Shorts, Instagram Reels. These are the products competing for users' attention. If your app takes too long to load, many users just will never reach the moment you designed as an important one. And if the app feels sluggish, unresponsive, they simply will not stay long enough to discover its value. A performant app, for me, it's not just a good benchmark. Performant app gives feedback early, it stays smooth during interaction, it uses memory and energy responsibly, and I can say it's keep doing this on real devices too, for real users in real world.
Do you think that do average lie when it comes to performance, Bogdan? Because we have what we call, I don't know, kind of FPS average, it's 60 frames per second. It's a good relevant of the performance of the application, or something that the screen load, it take, I don't know, 100, 200 milliseconds on average. It's a good indicator of performance. What do you think about that?
Yeah, it's a good question. And I first want to highlight, I really like what Artem said here. I think performance is very important and it usually requires proper measurements. So we have these two different measurements, like he just said. So there's developers that can measure things on their own devices, but we care about what happens on the real users' devices, right? So in that regard, as measurements are very important, then we ask the question, okay, what measurements? So your question is very neat because it touches these myths about average. So if we look at average, we can draw the right conclusion, right? So for instance, we say, well, our FPS average on this screen is 58. So then we're okay. Or this screen loads on average in 300 milliseconds, or CPU usage across this feature is around 20%. But a particular user would not have the same experience of an average. So what usually happens is many users have that 58 FPS, but there are some users which see hitches during scrolling, maybe a 500 milliseconds freeze, sometimes a very slow app launch, maybe the 10th time they launch the app, it takes 2 seconds. And these are not the averages, right? As we understand statistics, average does not represent for all the cases, but it's actually like a measurement of all of them. So there probably are better ways to look at this. Of course, average values do matter. We don't ignore them. But besides looking at averages, we also look at, let's say, P95, P99, which basically mean we say, okay, on average, this screen loads in 200 milliseconds. But for 95% of users, what is the actual slowest value that they get? That 200 milliseconds can become a 400 milliseconds on a P95 or 800 milliseconds on a P99 for the boundaries of these intervals where users have the worst performance, right? So this shifts the way we look at the same data in the same interval, because now we see explicit, let's say, that the user has 800 milliseconds of load time in that screen where we say, we're okay, we're at 200. Well, they have 4 times worse than that, right? So that changes a bit the way we look at these. Also, consistency across screens, across users, across OSs and everything is much better and more important than having peak performances like Artem said on a very powerful device where we are, let's say, perfect, but on other devices we have these glitches, right? So we need to look at all of these distribution equally. Same thing like we discussed frames per second, which is basically feeds into frame pacing, which cares about basically how consistently frames are delivered, and that is more important again than the average. So the same thing with, let's say, from a first-time interaction with a screen or with a app launch, which is very important because we do care where the user can actually interact with that part of the app, and not necessarily look at the maybe incorrect measurements that tell us, let's say, app launch or screen open, but they don't account for all the things that are blocking the user from actually using that part. So all of these, I think, are feeding into the measure, which is measuring is very, very important for performance, and measuring has various, let's say, different pairs of glasses that we put on when we look at the same data we have. So we don't always have to rely on what perhaps a tool like Firebase Analytics would tell us. We have other ways to look at that data. So I hope that answers your questions about averages.
Yes, along the years, I have noticed that engineering and user often speak completely different language, and when it comes to those kind of performance, speaking about FPS, peak performance, frame space, all these metrics. But also as developer, we tend to look at metrics, which is normal because we have, and also from product owners, what we call stakeholder, they need to have this kind of metrics. Okay, the metrics from our point, it's not the same from the other, it's not the same from the final user, from the stakeholder. There is different metrics, but from our perspective, things like CPU usage, memory consumption, FPS graphs, like you mentioned, startup duration or launching time, we speak about this later. But when a customer leave 1-star review, we know this, that we find in the Apple Store, they rarely say your frame pacing is inconsistent, or your, I don't know, P95 latency is too high. They say the app feels slow. And sometimes that's what makes performance such, if you can say, interesting topic, because we cannot evaluate from the same manner, like a final user, like a developer, like a stakeholder, like a designer. There is different kinds of metrics. That's why my second question to Artem is what, how can an application be technically fast? From our point of view, developers really amazing. We have all the metrics are good, but still feel slow to the user, to final user of the application.
Yeah, it's a good question. Users, they not experience performance as a profiler trace like we. So, but they experience performance through, I like this definition, through small signals from the UI, from the interface. For instance, imagine a screen that loads in 700 milliseconds. That may be fine on paper, but if the screen is blank during that time, the user is left guessing, did my tab work? It's quite an uncomfortable situation for user. So I usually care a lot about time to first feedback and then time to first meaningful content. So a transition, a skeleton view, or a partial content tells the user the app heard you and something is happening. Under the hood, the app may be doing exactly the same amount of work, but it will feel much faster. On a product screen, you can show the title, price, cached image first, then load reviews, recommendations, secondary blocks just later. The full screen is not ready yet, but the user already understands where they are. For me, it's mostly about, trust. A spinner is something fine when you show the spinner a progress view or something like that, but it often says something like, please wait, but no details, just wait. And skeleton loading or progressive rendering gives more context. It shows the shape of the result. Another good example is optimistic UI, but I should say that I would use it carefully. For example, for reversible actions like liking an item, bookmarking something, updating the UI immediately it feels right. You just feel something right. But for payments, anything secure, critical, the app just should not pretend that something succeeded before it actually did. So another thing I think which is important is something small but annoying, small interruptions. My favorite example is a feed. So in feed, for example, I would rather start loading the next page before the user reaches the last cell. When loading starts too late, it feels like the user hits a wall of nothing. No content, I just need to wait something. However, also the opposite situation. It's an interesting case, a very rare, but it exists. If the app says, for instance, I'm calculating recommendations based on your profile, and the result appears immediately, some users may trust it less. It can feel fake for them. In that kind of flow, a tiny bit of visible processing can make the result feel more believable. And in both situations, the goal is to make the UI match the user's expectations. Perceived performance is about giving feedback, giving it early, introducing uncertainty, keeping the experience moving. Users today have very high expectations. So making this expectation is an important part of building a good product experience.
Yes, and I think this expectation is coming from the new generation using a lot these tools. Maybe they have also a high level standard in using this kind of application. And what I really understand from your the idea that you try to share it with us, Artem, that perception it's very important. For me, it's matters more than metrics that we have. And when we talk now with perception today, especially for iOS modern application built with SwiftUI, I think that we supposed to make building interfaces easier using the declarative aspect of SwiftUI, this great component that we create with high level standard when create our UI component. But I'm still curious about whether it's also changes the way we think about performance. Because as you know now, Artem, we have SwiftUI that simplify a lot our working, but it should simplify also performance or just hidden some costs that we didn't really understand.
SwiftUI is a deep topic, and I think SwiftUI made UI development really much simpler. But when we talk about performance, I would say it made the cost less visible for us. With UIKit, a lot of things were very explicit. You could reload data, configure the cell, updated constraint. You usually had a pretty direct feeling, okay, this action costs this work. SwiftUI is a different thing. You change some state, and the framework decides what has to update under the hood. But this work still happens somewhere. There's no magic. It happens. And because of that, it is easier to create performance problems without noticing them. Ask yourself what changed, who reads that state, how much of the screen wakes up because of it. It's a good question when you build a view with a SwiftUI. And I can say that SwiftUI changed the mental model. UIKit, I often asked something like, which method did I call? And in SwiftUI, I ask, which dependency did I create? So my practical rule when working with SwiftUI, I should keep state close to where it used to understand it better. I should keep identity stable and keep body boring. I think this is the right word. When those things are true, SwiftUI can be very fast. Maybe not as fast as UIKit, but it can be really fast. When they are not, you usually discover the cost, but later through the instruments or during scrolling on some different testing device or in MetricKits later when users just don't like to use the app.
Yes, great. From my understanding, though, now I think that many of us had great experience with declarative code using SwiftUI, and we feel very productive using SwiftUI because it's much easier to use this kind of declarative code. And we write now less code. We get previews. Okay, we know that since WWDC last year, we have this ability also to have previews using UIKit. But I know that a lot of developers use SwiftUI for previews because they have to see everything that they did when coding. I think also that kind of things related what we call state management feel much more natural when using. And okay, but we have this idea that SwiftUI, it's for small features. It's hard. It's hard also to not love it using SwiftUI. And also what we see at WWDC that the example are so simple, sometimes are very interesting, very complicated, but this is the main idea, to have this kind of little features using SwiftUI. But when the teams grows, when the requirement become much more complex, and suddenly some decision, you speak about pagination, things related to pagination, and we have a lot of rows to scroll, and we have this kind of pagination, and we have sometimes real impact of performance when we have a lot of data to retrieve, even when we're using pagination. And that's why if we can say that this kind of Swift UI pattern, a lot of data binding, some kind of abstraction, sorry for the term, but sometimes it becomes toxic at scale. What do you think, Artem?
Yeah, I agree. And however, I should note that a common SwiftUI screen can get away with a lot. You can use a large view model, observable object. You can use conditional views. You can use any view. It's not pretty, but it works. But feature grows, screen grows, and view grows. And before long, you notice that a tiny state change seems to wake up just, I don't know, half of the screen. The example I have seen many times is one big observable model behind the whole screen. And this is, I can say, a toxic pattern. Something like screen view model with many properties, and every child view reads from it directly or indirectly. It feels convenient at first, but later a small change can make much larger part of the hierarchy revealed than you expected. The observation framework helps here because it tracks property reads more precisely than observable object from combine. However, it's not a silver bullet. What I usually try to do is create small dependency islands. Subview should read the smallest slice of state it needs. It's also a good way, I prefer this way, to create real subviews over helper functions or properties, because real subviews, they give both SwiftUI and you better boundaries, better understanding how to deal with it. And if we're talking about toxic patterns, the other one, I can say it's when you call out a real work inside body, sorting, filtering, formatting. When you build display data inside a body, it may look harmless, but becomes part of the update path because it's not just declaration of the UI, it's a executable code. And during scrolling or frequent updates, that can eat the frame budget very quickly. As before, my favorite example, a feed screen, because this is the best stress test for every view. I would rather prepare render-ready row models for this screen when the data changes and keep the SwiftUI row mostly focused on layout. The row should not be deciding too much or transforming too much while it is being rendered. Another toxic pattern that comes to my mind is unstable identity. It's a classic one. If list items do not have stable identifiers, SwiftUI has a harder time understanding what actually stayed the same. It's about SwiftUI diffing. And my general advice and general thesis, boring SwiftUI code usually performs better than the clever one.
Yes, great. As you mentioned, Artem, about what we call broad observable state, if you can say that as a toxic scale pattern, and especially also about dependency boundary. Bogdan, you have spoke quite a lot enough about using what we call the environment propagation, using the environment property that we find in SwiftUI. I think that you have an idea about this impact of using environment propagation, also on the performance and also of respecting kind of solid principles.
Yes, of course. And I'm glad that Artem did this very, very nice brief insight into the specifics of SwiftUI as a framework and as a declarative framework. If you know me, I'm more of a geek and looking at design principles from an architecture point of view, from a API design, things like that. I'm a big believer in solid principles. I don't always follow them, but I do believe in the case of SwiftUI environment, we do have a kind of a mismatch with solid. And let me explain a bit. So first of all, what is the SwiftUI environment? This is a mechanism that allows various objects to be propagated implicitly. This is very important, implicitly down the view hierarchy. So views don't care how these dependencies are resolved for them. And in contrast, an explicit dependency would be one where you pass, let's say, directly through the initializer of a class, so like a view model depending on the service or something like that, right? Where when it's implicit, you just, for instance, in SwiftUI, use at environment object and define a dependency that will be resolved at runtime through a mechanism which you really don't care or you don't know much about. And this is great. This helps a lot with setup, and it's great for truly environmental concerns like theme, like locale, like some kind of configuration that is app-wide, things like that. In my view, where the problem arises is when this SwiftUI environment becomes the default dependency resolving mechanism or DI mechanism. And this is because these hidden dependencies just violate the spirit of solid, because the dependencies are no longer obvious and the components that depend on them are harder to understand in isolation. They're harder to maintain, to test, to debug, to profile, because they depend on so many things that are not visible. So, and I think the worst one of them for me is runtime crashes, because this is just not just a logical, let's say, imperfection, is something that affects users. It affects development teams that have to deal with these incidents in production. And this can happen easily by an incorrect setup of all these environment objects. And I'd like to share some story here where actually multiple teams that I worked with over time notice this, that when they have this implicit way of resolving dependencies, that with a simple code change in production, sometimes even due to a change of a feature flag on A/B test, so no change in the actual code of the app, the setup can be broken, and that can lead to this crash where I'm referring to, where you basically will get a crash from SwiftUI when trying to access that dependency that is not set up. So to me, this is magic, and I'm a strong believer that magic and surprises should not live in the code base with us. Things should be very explicit, very easy to see. And the other problem with the environment object is they grow and attract things like cross-cutting concerns, authentication, analytics, feature flags, navigate, all kinds of things become easily resolved through environment dependencies. And another concrete story, which I think is relevant to this case, it wasn't for SwiftUI particularly, but it's a time where we unfortunately reinvented the service locator anti-pattern. And I think
Okay.
the SwiftUI environment can become this service locator anti-pattern if used incorrectly. So basically what happened in my case was we had a large UIKit app and we tried to avoid passing multiple dependencies. So we also were allowing components to create their own dependencies, which is also a smell of an imperfect design, but let's not get into that because the motivation was good. We want to write less boilerplate. We want easier access and setup for our components. We, instead of having like 10 parameters for each init, we just have one, the entire environment object that we used, and it led to faster development, right? And this one large environment object basically had a reference to all the app level services or state managers that we needed. And everything was easy, but easy is not always good. So over time, like I said in the case of the SwiftUI environment, components started depending on more and more things because they were right there to be used. View models accumulated a ton of responsibilities. There was no clear boundaries. There was no obvious answers to questions like who owns this logic? Why is this component talking directly to analytics or to persistence or to things like that? And everything basically became accessed from everywhere. So we kind of reinvented a spaghetti architecture. And this is later I found out that this is called the service locator anti-pattern, where we basically let a single object resolve all our dependencies for us, and we are immune to how these are resolved, how many of these we use, and things like that. And it really violates single responsibility principles because components are so hard to understand, and you touch so many things at the same time in the same component. And there's no boundary to stop you. At least when you have explicit dependencies in the initializer, somebody reviewing your code will see like, okay, now you added 5 more dependencies. Something is getting out of hand. But when they're implicit, nobody sees the problem. And like I said, it leads to these problems with the production code. The tests are, if you have tests and you're trying to write tests, they are becoming more cumbersome. They require a lot of setup. They are harder to maintain over time. So people write fewer tests because they're so hard to set up. You end up having to mock all the app services in a, I don't know, simple onboarding view that you need to test because it depends on everything. So now you need to mock or test double everything there. So I think it's just an overuse of a good solution, but for the wrong use cases. So I would say, like, if I have to summarize here, is probably like explicit dependency injection is more verbose. Yeah, I agree with that, but it's safer because now the compiler can help guarantee that these dependencies exist when we try to instantiate the objects that use them. So that is, to me, very important and has worked very well over time. Environment propagation, like SwiftUI environment, is more convenient. So convenience usually often wins early, but explicitness wins at scale. That would be my, let's say, condensed version of this. So if I have to give like a short formula, I would say use environment for environmental concerns and use explicit state for dependencies that deal with business concerns. And I think that's about it. And with any anti-pattern, the bill arrives one day or the other. So be careful about it.
Yes, I think it's much the example that you shared about environment. It's really the same example that you have with singleton pattern. It's like we often use it that the community now when they see you code with singleton, it's anti-pattern, but singleton it's a good choice when you use it for correctly, if we can say it. And this is the same
Yes.
problem of with the environment. With the environment we have, hopefully we by the time we try to use it correctly because it reduces boundary, okay, and the reducing boundaries create a lot of problems when we come to modularization. We have this kind of feature that should not be dependent. We know that we have sometimes shared thing information to share between features, but using this kind of we face this in our application, let's say for some developers, even using boundaries to pass from, I don't know, from the PLP product of list to detail his product sometimes, and okay, we need to pass this information. But I think sometimes we need to have another solution. We need to speak with the backend to have this information, not to passing from the interface to the other using environment. Sometimes we have this kind of choice, and we need to be very intelligent when using this kind of variable, because it impacts after our performance. Problems would be accumulated by the time, and I think it's a good thing that you spoke about this, Bogdan. Thank you. Let's
Thanks.
come to Artem speak about a little bit about the feed re-rendering using SwiftUI. And this basing, I think, about what we call the diffable things. Diffing, it's a mechanism that exists in SwiftUI now, and re-rendering, it's very huge things about performance. Do you think, Artem, that SwiftUI mechanism of diffing, it's become like a button now in the very huge application of very complicated and interface?
Before blaming diffing, I should know that a lot of SwiftUI hitches come from other things. Most of something like too many view updates, or some view is doing work it should not do. But I start thinking about diffing when the structure of the view becomes unstable. I remember a developer once came to me and with a strange SwiftUI issue, strange at first glance. He had a text field and he applied a custom if modifier, conditional modifier. Conditional modifiers can look very tempting, but they have some hidden caveats. It's something like if this flag is enabled, apply one modifier, otherwise keep the original view. And the code looked clean, very SwiftUI-ish, but when the flag changed, the text field lost its state. And you look at the screen and think, is it still the same? It's still the same text field, right? But SwiftUI can treat the modified and unmodified versions of this text field as different entities in the view tree. That was the problem. The view will be recreated. And the same thing happen when the structure of the view tree changes frequently. When elements have unstable IDs or IDs that get recreated on updates, when any view is used heavily, or when a list changes order, gets filtered, regrouped. In those cases, SwiftUI has a harder time matching views to their previous versions and may need to do more work during these updates. So I would say diffing becomes a bottleneck when SwiftUI has to compare too much unstable UI too often. The fix is just simple, just not outsmart the framework. Keep the structure simple, boring, predictable, and that's it. Some developers also recommend making Vue conform to Equitable protocol to reduce unnecessary updates. However, personally, I would not do that by default. SwiftUI is already very good, really very, very good at comparing values and deciding what needs to change. I only reach for Equitable in exceptional cases where I have clear evidence that it helps. In most situations, I would rather trust the framework than introduce extra optimization that could accidentally hide legitimate updates and create bugs that affect the user experience.
Miss, great. I think what's interesting that is that diffing now often gets blamed for performance issues, but there is other things in practice that you said now. The framework, we should trust the framework, as you said, and maybe there is other thing that competing we get for some precious milliseconds, and that's come to my question to you also, Artem, about what we call the frame budget, which is very important now in the community, especially when we have last time I read a book about this. about this kind of SwiftUI way and also the budget related to the frame in modern iOS application, especially when we have this kind of new devices. Sometimes when I I think about frame budget with this great devices, and also we continue to speak about frame budget. Do you think that is good questions now in modern iOS application, even with this great devices and new iOS?
It's a very good question, and we should take it into account every time we develop a SwiftUI app and any app. And the important thing is that frames are usually dropped because many small costs accumulate in the same frame. For instance, a state update can trigger view re-evaluation, layout, drawing, etc. And all of that has to fit into a very small time window before the next frame should appear on screen. A good example is a simple text view in SwiftUI. It looks innocent, but formatting attributed strings can become surprisingly expensive. And the best stress test, as I said before, is scrolling, because scrolling puts the whole pipeline under the pressure. So if the screen has little performance headroom, scrolling will expose it very, very quickly. And because of that, it's very good stress test. If we're talking about SwiftUI, I should say that for very sensitive scrolling screens, I still prefer UIKit. I still see UIKit as the strongest choice, especially for heavy feeds or BDUI, because we really don't know how it will compose the screen. It has a very deep layout tree, and by UIKit, I don't always mean an auto layout. In the hottest path, frame-based layout can still be very powerful, and for this place, it might be the best choice. But SwiftUI has improved a lot, especially since iOS 18, but I would still be careful with container choice. List is usually the safer option if we're talking about SwiftUI for large vertical content, heavy feeds, etc., because it benefits from collection view infrastructure under the hood. Also, I should note that there is still an additional update coalescing collection view layer between list and underlying collection view. An extra layer, an extra view, which is unlikely to make it faster than lean UIKit implementation. Lazy stack is more customizable, for sure, but I would not automatically use it for a heavy infinite feed. I would always profile it on the minimum supported OS on real devices, and a good stress test is also a low power mode. It's very convenient. If you don't have access for an older iPhone, you can enable low power mode and it will help. And on speaking about feeds, on the GPU side, the usual suspects are things like overlapping layers, masks, shadows, blur, glass effect, and even gradients. None of these are bad by default, but during scrolling, you can find that they can become too expensive. So if we're talking about frame budget, it is consumed by everything that happens between a state change and pixels on screen. View updates, layout, drawing, different image work. Each piece may look small, but when they all arrive in the same frame, it will be definitely a hitch. So we should try to avoid it.
Yes, it's really funny because every time we speak about performance and discussion, become very, very serious, and somebody end up talking about UIKit. We speak a lot Okay, just for fun, we didn't have now for the WWDC a video about the new things in UIKit in this last episode. But we start with SwiftUI. We talk about what we call the re-rendering of the body updates of our view. We also spoke about state propagation, kind of rendering cost, and well, we have always the control using UIKit, like you said, Artem. Which brings me to another question related to UIKit to Bogdan. Simple question. Do you think that UIKit is deprecated now, or we can continue? Even with the WWDC that we didn't have a video about UIKit.
If I say yes, then we can go to the next question, right? No, I'm joking. I mean, yeah, we especially us that we started development years ago, we learned UIKit, so now we try to still fight for it, right? I think it's, like, joke aside, like Artem said, a matter of choosing the right tool for the right problem instead of being puristic and saying, no, I only do this or I only do that. So, but first let's explain what deprecated is, because you asked me if UIKit is deprecated. Well, a deprecated solution from Apple would mean that Apple is clearly signaling us to stop using it because it will go away. And it happened with various APIs, with frameworks and things like that. But in my opinion, UIKit is still stable, is battle tested, if you want. And even if it evolves more slowly, it still remains fully supported. And you might ask, okay, what am I basing this on? Well, first of all, Apple still ships new UIKit APIs, and UIKit continues to receive improvements. Then major Apple apps still rely heavily on UIKit. And now that you mentioned WWDC, well, yeah, we didn't get specific UIKit sessions, but we continue to see UIKit interoperability being mentioned over and over with SwiftUI. So to me, the narrative that UIKit is deprecated is just inaccurate. And another evidence for that is something that I like Artem also mentioned, is that SwiftUI itself relies on UIKit for rendering in some situations, not all. And this may surprise many people, especially in the example that Artem mentioned about how a list actually relies on a collection view behind the hood, under the hood to render all these dynamic elements. And this is because in many situations, SwiftUI delegates to UIKit to display and manage these views. And also SwiftUI, I think, wasn't built as a complete replacement overnight. It was layered and built with decades of UIKit knowledge and infrastructure being available for it. So in my opinion, they both excel at different things. So they're different tools with different trade-offs. And we can use both, which is amazing, I think. So SwiftUI, because it's the new item and the new tool, is perfect for static screens, for forms, settings, reusable components, where composition is really at the core of how you build your UIs. And I really like and support that idea. Like you mentioned, valid previews, which allow so much faster iterating on the UI, with the caveat that many teams cannot use them because of how their dependencies frameworks are set up, and sometimes SwiftUI previews just don't work. But that's let's say a case-by-case situation. And of course, SwiftUI reduces a lot of the boilerplate that we were used to with UIKit. On the other hand, I think probably the same idea that Artem just shared is that UIKit is very strong on highly dynamic screens, maybe with multiple data sources, infinite scrolling, infinite feeds, paging, prefetching, complex scrolling behavior, like all of these are still better represented in UIKit. So to me, the hybrid approach is often the sweet spot. And I think the biggest mistake here is just treating this as a religious war. And I've seen, if not people bragging with this, but at least job ads that really emphasize the fact that we only do SwiftUI, like that would have some kind of a hidden value to it. To me, it's more of choosing the right tool for the right problem. And with the interoperability that Apple has built, I think we can do that. So I would leave you with this on this topic. So just ask yourself, are you choosing the framework based on the requirements or based on the trends that you think are out there? And just think about which tool fits the problem best. That would be how I view this.
Yes, great. But sometimes, Bogdan, choosing it's related to the generation because people, new developer that comes, know about SwiftUI, their integration with code that using UIKit, it's not easy. Sometimes also for the career of the developer, because a lot of company asked to have SwiftUI, they didn't have this kind of thinking, okay, maybe we need to also to have UIKit in the offer of jobs. You see only SwiftUI. And I understand that sometimes it's not related to the developer how he or she accept to using SwiftUI or not. I know that we know that's much easier to use SwiftUI in terms of declarative code, much easier on number of line of codes. But thinking about performance and things related to adopt UIKit in some situation, it's not for all the developer to think. And this is the target or the goal of this episode to speak about to thinking about using this kind. It's not okay because SwiftUI it's new that we adopt it for every situation. We need to have this kind of time of thinking about it's suitable to adopt this like you and Artem shared about it's kind of complicated view when we have data that come from different data sources and we have a lot of interaction with our views. Like I said, the great example, it's the home page we have now in a lot of application we have, okay, we have this part related to EI, we speak of with a chatbot, we have recommendation products, we have search, we have sometimes related to fidelity program. We have this in our application when and we adopt to using UIKit. We have debates now to adopting SwiftUI. And I think it's based on performance because we see a lot of developers adopt UIKit in this use cases. For me, whether we're talking about SwiftUI or UIKit, sooner or later teams run into performance issues. We have this frustration or part is that the tooling. We have a tooling. We have instrument profiling. Now we have also tooling for concurrency, Swift concurrency now to check if every task working great. But sometimes we doesn't have immediately the answers. What do you think, guys? I don't know, Bogdan or Artem, have you ever faced performance issues, problem that instruments like great tools that we have now on Xcode didn't clearly explain?
Of course. That's the short answer. Because, I mean, to me, performance work and performance investigation is kind of a, let's say, like a detective's work. You don't easily get to the response, to the root cause of the thing you're investigating. So it rarely happens that you open a profiler in instruments and you immediately get the answer. It's more of a, you observe some things, you make a hypothesis, you experiment, you verify it, and after a few cycles of this, you get to the actual problem that you were looking for. So I would like to maybe give some tips or some principles to apply when doing these kinds of performance investigations, which unfortunately or fortunately I've done a lot over the years. So first of all, I would say never trust your first explanation, or at least challenge it, because the most obvious suspect is sometimes innocent, and you need to think about what actual evidence do I have to support this. Then, of course, we formulate hypotheses, and we need to eliminate these hypotheses going one by one. So it's kind of like a scientific process, if you like. You form a hypothesis, you change one variable, you measure, you accept or reject the measurements, and just avoid changing too many things at once. Just change one thing, measure again, then you can have more accurate results. Another important principle when investigating these kind of issues is trying to reproduce the situation. So even if it's not obvious to reproduce, you can think about, how can I reproduce this? Under what conditions? How often does it happen? If you can't reproduce it, you probably can't fix it reliably. Another important point is to measure before and after, so you can compare the results and not just optimize blindly and think that the problem has gone away, because it usually doesn't. Something that I noticed over time is in many situations the symptoms are far away from the causes. So for instance, the UI is freezing, but it's because of some blocking networking call, or scrolling is interfered with by, I don't know, image decoding that happens, or battery drain is caused by polling. Or so the idea here is that the stack trace is not always the problem. Doesn't always show the problem at the top. Then what I like to do when I do this kind of investigations is build some kind of a mental model, because tools help us observe things. They observe, they highlight things, but then we need this engineering mind to be able to explain and formulate the hypothesis for this. Something that always helps is reducing the problem, because usually when you're dealing with a problem, I can think of the first example you mentioned at the beginning, where it said the user says the app is slow. Well, what does that mean? So you try to reduce the problem. Like, can I disable a feature? Can I remove a dependency? Can I isolate like a screen or a specific scenario? And making these things, these changes, and these are not changes that you push to the repository, is just something that you do during the investigation to help with your hypothesis, help you narrow down the problem. So let's say if you disable a bunch of screens from your app and the problem still occurs, then you narrow down where the problem might be happening. And same with dependencies and things like that. Another important point would be to make sure that the work that is happening needs to happen, and needs to happen in that context. So think about what, why, and who is responsible for this work, and if it's necessary, and if it's the right context. Be careful with confirmation bias, because once you have a theory, your mind is trying to find all the evidence to support it. So it happened to me many times where I actually drew a wrong conclusion at some point and ended up with no results at some point later, because I didn't actively seek for evidence to disprove my hypothesis. Like, okay, see, you can look at this as a changing hats between writing production code and writing test code, which is a perfect anecdote that Ken Beck shares when explaining TDD, right? So you kind of change hats, so you change your mindset. This is the same. Now I change my mindset to, okay, how can I break this theory? Is there evidence that contradicts it? And this helps eliminate this hypothesis and get to the one that is correct. And of course, optimizing the biggest bottlenecks first helps a lot, because then you can remeasure, and sometimes the problem is in a much better state that you don't need to go on. And I'm saying this because sometimes I think Artem mentioned this as well, we're so committed to fixing all the problems that we found, and maybe out of the 3 issues we found during measurements, 2 of them just lead to, 50 milliseconds improvements. And it's just not worth spending a lot of resources like time and energy on these if the measurements are in your favor after you fix the biggest one. So to bring some concrete visualization for this, I can share some real case scenarios on these kind of investigations that I did. So one that I remember was during my time with SD Web Image, where I was one of the maintainers there. This was a Objective-C library for image caching that thousands of developers used. I'm saying this because there might be newer folks that have never used it. And at some point, we got a lot of reports about UI freezes and scrolling degradation in table views or collection views with these kind of cached images. So, of course, initial hypothesis was something like a disk read or write or processing on the main thread. And basically, we were checking all the operations that were transforming bits of data into instances of UI image. And that turned out to be wrong, because the actual culprit that we discovered after weeks of investigations was that Apple was using some kind of behind doors decoding mechanism for images that was running on the main thread, and it was not a direct consequence of an API call we made, but it was happening. And since we didn't have control, we experimented a bunch with various things, and at some point somebody, I think it was actually one of the contributors that found a way to do decoding on a background queue, which was kind of revolutionary at that time, because it was like this unknown black box where you try different approaches, and in the end, hopefully we got to this happening. Of course, this is a long time ago, but I think it's still relevant because we were misled by, let's say, common sense, and we didn't actually found a way to measure and formulate the right hypothesis. And on the contrary, or in hindsight, I can think of many moments where I did optimizations that didn't move the needle in terms of performance. So I just tried different things, and they didn't matter. They didn't improve performance. One which I remember clearly is, at some point I was investigating some memory allocation in a big app, and the allocations tool was showing like a lot of string usage, string objects being allocated, and a string, of course, back then. And I said, oh, okay, then this must be the problem. So I started to do like a big revamp of the biggest strings in the app and how we handle them and things like that. So I think I worked a few days on this, and then when I remeasured again, there was no difference. So you can say that I just threw away some really useful resource, like the time to work on something else on a hunch that didn't turn out to be true. So again, being young, I didn't stop and measure, at least at first. So I went on with the whole idea, and then just had to be disappointed at the end. Yeah, and something else which I would like to highlight is something I see in a lot of teams, which is the problems that reproduce in production, on the production environment, that we cannot reproduce locally as developers, or our test engineers cannot reproduce them because they have particular situations, particular context that enhances that problem to appear. So once you gain experience with these kind of things, you start to use older devices, like we mentioned, also low battery mode, like Artem mentioned before. Very good to force these kind of conditions. Also the network link conditioner to test out a bit how your app is performing under certain network limitations, which can lead to these kind of problems. And there's more here. So the lesson is just that context matters so much. And if I have to say, in my experience, many optimizations came from subtraction, not by addition. So basically just removing work that's unnecessary, and or at least move it to some place that has a lower impact than the obvious operation that is being affected. So I hope
Yes, it's great. Bogdan, we come with different kinds of examples that we didn't detect using tools, sophisticated tools like instruments. We know that it's not easy also to adopt instruments. It's kind of tools that now, I don't know, dedicated to senior or confirmant developers. But maybe now, maybe with using LLM now, it's much easy to adopt it, because sometimes it's not easy to read the stack of the calls and come to detect the problems. For me, honestly, it's not easy, and it's even with these tools, we need to have this kind of scenario or stories. Artem speak also about MetricKit. I think that maybe you have an example of using the storytelling about using and adopting this kind of framework.
Yeah, I'm a big fan of MetricKit, and I want just to highlight the idea that Bogdan mentioned. Sometimes instruments does not give you a clear answer just because the problem is outside the scenario you are profiling right now. For example, imagine this situation. First line support starts getting complaints from users saying that the app drains battery very quickly, and most of the complaints come from people on older devices, something like iPhone 11, 12, something like that. Not ancient phones, but not the newest ones either, and often with the batteries that are already a bit tired, I can say. So naturally, you open Time Profiler and nothing looks suspicious. You ask QA to pay attention to battery behavior. They test it. You ask them to test it on older devices. They test it on older devices, and they still say, no, we do not see anything strange. And the right move in this situation is to look at MetricKit reports too, because it can show what actually happens on real devices. For instance, the clue may be location activity. You may find that the app keeps doing location-related work and doing it much longer than expected. The realistic cause is location manager, CL location manager, that is accidentally kept alive. For instance, there is an old map screen in the app. It is built on an older architecture. It is hidden quite deep in the product, and nobody has touched it for a long time, like in the app I worked on. And QI checks them only during a full regression before release. But everyone forget about it, but users not. Some users still open that feature and eat them up. UModel, for example, keeps the location manager in memory. The app can continue paying the energy cost after the user leaves this screen. So inspecting it via memory graph may also not help unless you know which screen to inspect. And production metrics can tell you, hey, on real devices, location activity is much higher than it should be. Instruments is great when you reproduce the problem locally and you know what paths to profile, but you do not always have that opportunity.
Yes, great. Thank you, Artem and Bogdan. I think what I really appreciate about performance, if you can say engineering, performance engineering, that it so often humble us. We'll be much more humble when you speak about this story, the story about SD Web image. We started really with we are confident in the theory, in our tools like instrument, like metrics, metric kits, but think that we know exactly what it's wrong. But after hours, or like Bogdan said, weeks of profiling, we discover that the real issue was somewhere completely different. And I think it's very often that this kind of investigation, that come to improve our seniority. It's important to understand this kind of situations, improve our seniority, um, because performance, like a topic, it's for me one of the topics that we can say, okay, it's this is a senior developer or not, or also there is things related to architecture, but this kind of things related to performance, for me, maybe I'm wrong, it's kind of a flag to say, okay, the developer, it's we can say that it's subject, it's topic related to senior level, but also sometimes that we think, as you said, that performance is related to things related to main thread, background thread, and we say, like Bogdan shared, investigation, it's really focused, okay, if you are on main thread or we are not on the main thread. Now with the Swift concurrency, we have this topic related to main thread, not main thread, but we will discover that it's not related to threading, almost Swift concurrency. We have this kind of people that assume that if something is asynchronous, it's automatically faster, because we think that, okay, we can fire and forget, something like like that. Do we think, first of all, that it's question, if you want, for Bogdan, that developer confuse a lot about concurrency and what we call parallelism, and I think that we have this kind of problem. Okay, it's not related to performance, maybe, but we need to focus on this kind of definition, and after this, maybe speaking about things related to performance, related to Swift concurrency.
Right. So I'm really glad you brought this up, Farid, because I strongly believe in understanding the root concepts of the domain that we work in. So to me, these concepts of concurrency, of parallelism, and others like memory allocations, heap and stack, things like that are non-negotiables in terms of understanding how the device we work on behaves. So maybe I'm more of a, I don't know, used to the old school way of learning. So these things were, let's say, theoretical at first, and then we saw how they are applied. But I do believe we need to understand these lower level concepts, even though in our days, like with, for instance, with Swift concurrency, we got all these abstractions that take care of, let's say, the lower level implementation of a thing like a task or switching context from one thread to another or things like that. Like these are abstracted from us, but I think there's a lot of value in knowing what actually happens behind these abstractions. So first, let's start a bit with the definition of each, because that might be useful. So concurrency is just managing multiple tasks that can make progress independently. And concurrency is usually about coordination and structure. Parallelism is executing multiple pieces of work literally at the same time. So when we talk about devices, this translates to utilizing multiple CPU cores. And if you want an analogy, let's imagine a chef. So our chef is cooking in the kitchen. So concurrency would be our chef juggling between washing dishes, chopping vegetables, water is boiling here, and all these tasks at the same time. So he's trying to do all at once, but as you imagine, it's a bit under pressure. Parallelism would be hiring for chefs. So each of them cook independently and at the same time. So I think that helps a bit understand how the system behaves actually. So to Valid's point, so a lot of people, especially like younger developers, believe that if something is asynchronous, then it's faster. And that's not necessarily the case, sometimes even the opposite. So concurrency does improve responsiveness, latency hiding, user experience, things like that. But also parallelism improves the total execution time for some CPU-bound work. So it's the solution that Apple, for instance, used in their Accelerate framework. You can have concurrency without parallelism. For instance, many network requests are coordinating efficiently and just a single CPU core is scheduling the work. You can have parallelism without some sophisticated concurrency abstractions when splitting CPU-heavy work across these cores. In my experience, most iOS apps are not CPU-bound most of the time. So they're not, let's say, hungry for more CPU power because most of the time they're waiting on network requests, responses, on database operations, on disk input, output, user input, and things like that. So if you want to imagine this, is the app is switching from processing to waiting for the next event, next state change that happens. So, and that's bound to how a run loop also works, because it's constantly doing some work, then checking, okay, is there a new request, a new event that needs to be handled. And by the way, this is the way older mobile, and not necessarily only mobile, but mobile operating systems worked, when they had like one thread and that's it. But those are antics, and let's not get into this. I think the key lessons here in concurrency versus parallelism is, one thing is, more concurrent tasks and more threads can lead to worse overall performance, because of thread explosion, which means basically we spawn a lot of threads, the system spawns a lot of threads, and the context switching between threads has a cost. So if you do a lot of thread switching, that cost will accumulate. And you may ask, okay, but where is the context switching? Well, remember that your device has X amount of CPUs, let's say 4. You can spawn 100 threads. There is no way the system can operate more than 4 threads at the same time. So if you want to do concurrency, then this means that one thread will run for a bit, then switch context, that CPU will execute instructions for another thread, and so on. So all of this back and forth is really accumulating. And another very important point that I learned the hard way is that identifying heavy working operations on the main thread and moving them from the main thread to background thread does not solve the performance issue, because the same CPUs have to execute that. It can get a bit better because now your main thread is more open to process the user events and the other things that are important for the user input and things like that. But overall, the same device is paying the same cost of that operation. So you may want to look at, okay, what is the actual cost of the operation and if I can improve it in some way. And of course, like we already mentioned a few times, the mantra: measure before and after. So you have like valid results. And I'm gonna go back to my SDWeb image days again, because we had another situation where we did this. We moved things, processing tasks from the main thread to background thread. And back then you had low-level APIs that you could force things to run on a specific thread. You could actually create a thread. Nowadays, it's not that easy, but in Objective-C, you could that. And like I said, having that computations on background thread still affected the main thread by keeping the CPUs occupied. So you still see the overall scrolling performance affected, especially on slower devices. So the solution in these kinds of situations is to actually improve the processing that you do, not just move it around on different queues or threads behind doors if you want, because that is not, I don't know, like the one silver bullet.
Yes, I think it's great. In this first part of our episode of talking about performance, we discover a lot of things with you, Bogdan, and Artem related to performance. But we think that we need another episode, another part for the episode. That we have now 1.5 hours discussing only some part related to Swift performance and also Swift UI, like topics related to Swift concurrency. And I think that we need to deep dive with Swift concurrency in another episode, and also let people, which we call digest this all things that we shared with him, because we speak about a lot of things related to Swift performance. And it's much, for me, it's much not logical, but suitable, if we can say it, that we have another part to speak a lot about Swift concurrency, about launching the app, and other topics related to performance. And that's why I try to thank you, Artem and Bogdan, for this first part of this topic, great topic related to Swift performance. And in the next week, we'll try to discuss other things related to Swift performance. Thank you very much to be with me for this first episode of the Swift Academy podcast. For people that didn't know about Bogdan and Artem, one of the real respected developer that in the community. Bogdan, we know, also Artem, creator of the maintainer of the SDWeb image and the Cocoa Lumberjack, and also mentor in the essential developer programs with other great developer around the world. Also, Artem, great articles shared with the community, and also very fine article about SwiftUI in depth with these topics. That's why we need to have another episode with you, with the community, and thank you a lot to accept the invitation, and see you in the next week.
Thank you, Walid.
Thanks for having us, and hope you are still awake after.